till long thereafter, today I will discuss some questions of complex analysis just as a review. Today I will discuss some questions of complex analysis about CSIR equation, differentiability, entire function. About this topic, today I will discuss some questions of complex analysis. Let's say first question, which had come in CSIR NET exam. But at first I will highly recommend you, please see today's video with pay attention. If you don't see and if you have any queries about this question, please do comments in comments box. Okay? Because today's topic is questions topic. The question f equal to u plus iv be an entire function where u and v be real and imaginary part of f respectively. If the Jacobian matrix, here the Jacobian matrix is, in the diagonal elements are uxa, vya and off diagonal elements are vxa, uya. If the Jacobian matrix is symmetric for all a belongs to C, then option 1 f is polynomial of degree less than equal to 1. Option 2 f is necessarily constant function, and option 4 f is polynomial of degree strictly greater than 1. Notice here, since the Jacobian matrix is symmetric, that means the diagonal element, this is the diagonal element, but since the matrix is symmetric, that means of this element would be same. That means Vxa equal to Uya. And since given the function is entire function, that means the function is complex differentiable in whole complex plane. Since function is entire, so it would be satisfy the CSIR equation. That means ux equal to vy and uy equal to minus vx. Then also I have got vxa equal to uy. Therefore, from 1, this imply uya means vx, vx equal to minus vx, that imply 2vx equal to 0, and since and it imply vx equal to 0, and this vx equal to 0, this is true for all a belongs to complex number. That means all part here, this is true for all a belongs to complex number, and since the function is entered, that means a prime also enter, and a prime means a prime z equal to ux plus ivx, and this is true for all a belongs to complex number. And since I have got vx equal to 0, that means a prime z equal to ux, and by Picard's theorem we all of us know, if the function only contain real axis, then the function is constant. That means a prime z equal to constant c, and this is true by Picard's theorem for all a belongs to complex number. That imply fz equal to cz plus d. That means function is a polynomial of degree 1. I hope my all viewers have understood this is clearly. Okay, OA. That means function is a polynomial, option 1 is right, and option 2, f is a polynomial of degree less than 1, less than equal to 1, this is also right, and option 3, f is necessary constant function, this is wrong, function is a polynomial, and option 4, f is a polynomial of degree strictly greater than 1, this is also wrong. because f is a polynomial of degree less than equal to 1. I hope my all viewers have understood this is clearly. Okay, well. Our next question, which had come 2020 June CSIR NET exam. The question is, for any complex function f, let df, here df denoted the set on which the function satisfies the Cauchy Reimann equation. Identifies the function for which df equal to c. Option 1, fz equal to z over 1 plus mod z. Option 2, fz equal to cos alpha x minus sin alpha y plus I times sin alpha x plus cos alpha y. Option 3, fz equal to e to the power minus 1 over z to the power 4 if z not equal to 0 and 0 if z equal to 0. And option 4, fz equal to x square plus iy square where z equal to x plus iy. For any complex value function, here function defined from c to c and df is equal to set on which the function satisfies the CR equation. That means df is the those set which satisfy the CR equation, and we have to prove df equal to whole complex number. We all of us know CR equation for fz at the point z0 where z0 equal to a plus ib is Cartesian form of CR equation at the point z0 is del u del x equal to del v del y and del u del y equal to minus del v del x, and the complex form at z equal to z0 is del f del l del z bar equal to 0, where del z bar is the conjugate of z. I hope my all viewers have understood. Here fz equal to x square plus iy square, where z equal to x plus iy. Okay. Here uxy equal to x square and vxy equal to y square. Then notice del u del x which is equal to del v del y equal to 2x and which is also equal to, since vxy equal to y square, this is equal to 2y. Okay, and del u del y equal to 0 which is equal to minus del v del x. That means Cauchy Reimann equation satisfies those line where y equal to x. That means df, since df equal to z belongs to complex number fz satisfies the Cauchy Reimann equation. This is the set containing x plus ix belongs to complex number where x belongs to R, and this is not equal to whole complex number. So for option 4, df cannot be equal to whole complex number. Next I will say, next fz equal to cos alpha x minus sin alpha y plus I sin alpha x plus cos alpha y. Here uxy this and vxy this. Then del u del x equal to del v del y means minus alpha sin alpha x equal to minus alpha cos alpha sin alpha y. Here alpha alpha would be cancelled, minus minus, and alpha alpha would be cancelled. That imply sin alpha x equal to sin alpha y. That imply x equal to y plus 2n pi. Alpha x equal to alpha y sin y plus 2n pi. That imply x equal to y plus 2n pi over alpha. That means df equal to z belongs to C such that fz satisfies the CSIR equation. That means this is equal to x plus I. Here x means y plus 2n pi over alpha times iy, where this is belongs to complex number, where this y belongs to R, and this is not equal to whole complex number C. So option 2 also not be equal. Now I will see the option 1. Next, fz equal to z over 1 plus mod z, we can write this as z over 1 plus square root of z bar. Here I will use del f del z bar, and del f del z bar would be z times 1 over 1 plus square root of z bar whole square times square root of z times square root of 1 over 2 square root of z, and this is equal to 0 when only z equal to 0. That means Cauchy Reimann equation will be satisfied only z equal to 0. That means df equal to z belongs to complex number such that fz satisfies CSIR equation. This is nothing but this is only singleton set 0 which is not equal to whole complex number. That means df here also not equal to whole complex number. So option 1 also not be satisfied here. That means option 3 would be obviously satisfied. Now solve this option 3. Fz equal to e to the power minus 1 over z to the power 4 when z not equal to 0. Notice here fz is independent of z bar. So when z not equal to 0, then obviously del f del z bar is equal to 0. That means Cauchy Reimann equation satisfies whole when z not equal to 0. Okay. Now we have to show the Cauchy Reimann equation satisfied at the point z equal to 0. Is e to the power minus 1 over z to the power 4 means e to the power minus 1 over x plus I y to the power 4. We can write this as e to the power minus x minus I y to the power 4 divided by, if we multiply by conjugate, then this would be e to the power minus x minus I y to the power 4 divided by x square plus y square to the power 4. And this is if we apply the rules e to the power minus x minus I y to the power 4, then this would be x to the power 4 plus 4x cube times minus I y plus 6x square times minus I y whole square plus 4x times minus I y whole cube plus minus I y to the power 4. And this value would be e to the power minus 1 over x square plus y square to the power 4 times x to the power 4 minus 6x square y square plus y to the power 4 times e to the power I times 4x square times x square minus y square divided by x square plus y square to the power 4. Okay, and notice this is the complex part. So this means this is equal to cos, we can write this as cos 4xy times x square minus y square divided by x square plus y square to the power 4 plus I sin 4xy times x square minus y square divided by x square plus y square to the power 4. That means uxy equal to this part when xy not equal to 0 0, and when xy equal to 0 0 then this is 0, and vxy equal to this part when xy not equal to 0 and 0 0 when xy equal to 0. X at the point 0 0 is limit h tends to 0 u 0 plus h comma 0 minus u 0 0 over h, and this value is limit h tends to 0 e to the power minus 1 over h to the power 4 over h, and put h equal to 1 over t. Then this value would be limit t tends to infinity t over e to the power t to the power 4. This is infinity by infinity, L'Hospital rule. Apply L'Hospital rule and put the limit, this value would be 0. That means ux at the point 0 0 would be 0. Vy partial derivative with respect to y at the point 0 0 is limit k goes to 0 v0 comma 0 plus k minus v0 0 divided by k, and v0 comma k, this value if you put 0 comma k, this value would be 0 minus 0 divided by k. So this value is equal to 0. Okay, that means Vy at the point 0 0, this value is equal to 0. Therefore, ux at the point 0 0 equal to Vy at the point 0 0. Therefore, Cauchy Reimann equation at satisfies. Similarly, uy at the point 0 0 would be limit k goes to 0 u 0 comma 0 plus k minus u 0 0 divided by k, and this value is, just put this value is limit k goes to 0 e to the power minus 1 over k to the power 4 divided by k. Similar, if we apply k equal to 1 over t, then limit t goes to infinity t over e to the power t to the power 4. So this value is equal to, similar to before, limit t goes to infinity 1 over, if we apply the L'Hospital rule, 4 t cube e to the power t to the power 4. This value is equal to 0, and Vx at the point 0 0, this is equal to 0. Vx at the point 0 0, this is equal to 0. So Cauchy Reimann equation satisfy at the point 0 0 and this value equal to 0. So only for this function the CR equation is equal to whole complex number C. So option 3 is only right option. Today I will stop here. In my next video I will discuss some same type of question of complex analysis, because complex analysis and these parts, CR equation, differentiation, interfunction, this part is very important for whole complex analysis. Okay, see you soon, stay safe and stay positive always, and don't forget to subscribe my channel for more videos. Thank you so much.